Hello, and thank you for clicking on the video PowerPoints for Chapter 12, Oxy-Fuel Gas Welding Equipment and Supplies, in your Modern Welding textbook. We'll go over the PowerPoints. I'll give you my lecture on them. We'll switch back and forth from the book and the PowerPoints. Hopefully this is a way that you can supplement your learning after you've read the chapter on your own, and this gives you or answers any questions you may have about the chapter. So let's get started. Okay, Chapter 12, Oxy-Fuel Gas Welding Equipment and Supplies. Our learning objectives for this chapter are to identify the various components of an oxy-fuel gas welding outfit. Describe the function of each component of an oxy-fuel gas welding outfit. List the safety precautions for handling and moving oxygen and fuel gas cylinders. We won't have to deal with much moving of the cylinders throughout this class. We keep our cylinders in two separate rooms located outside of the building, so we won't have to move them as much as you would, say, in your mid-course or something like that. But when we do get into the shop, I want to take you guys on a tour, show you around the shop. We'll take you outside, show you where the rooms are. We'll show you where we keep our full cylinders and our empty cylinders in case we do have to change them sometime throughout the class. Cite the maximum safe working pressure for acetylene gas. If you watch the video on Chapter 1, Safety in the Weld Shop, you've heard that about 5 different times. Max working safe pressure for acetylene gas, 15 psi, anything under 15 psi. For our welding, we'll have our acetylene set at 3 psi, so we should never really get close to 15 psi where acetylene becomes unstable. List all the safety equipment that's shown and it should be worn and used for oxy-fuel gas welding in various positions. A lot of that is going to be reviewed from Chapter 1 as well, the proper PPE. Interpret the AWS letters and number used for describing an oxy-fuel gas welding rod. That's our filler metal. Oxy-fuel gas welding station. An oxy-fuel gas welding station includes oxy-fuel gas welding outfit, a welding table with grating and fire bricks, ventilation, which is our fume collectors, lighting, and other equipment for the welder's safety and comfort. An oxy-fuel gas welding outfit includes the basic equipment needed to weld with oxygen and fuel gas. Components of an oxy-fuel gas welding outfit: gas supplies and fuel gas cylinder, regulators with high and low pressure gauges, hoses with appropriate fittings, a complete welding torch, welding goggles or glasses, and or a welding helmet, and a spark lighter, which will be the last time I reference a striker as a spark lighter to ignite the welding flame. Again, that's back to Chapter 1. We don't want to use matches or a cigarette lighter. Oxy-fuel gas welding outfit. Here's a look at one. Try to zoom it in a little. If we start from our welding torch and kind of work our way around the diagram or the drawing, we have our welding torch with a welding tip in there. It is screwed on to the torch body with a hex nut, our torch body. Then at the bottom of our torch is our, on the right, acetylene valve, which I'll call a needle valve. On your left is an oxygen valve. After the fittings for your torch and before you get to connected to your hoses, we're going to have flashback arresters. We'll talk more about them later in the chapter, but they're put on there for safety precautions. They usually have a check valve inside of them so that the flow of gas only goes in one direction. And also, if there would be a flashback or a backfire in the welding tip itself, that spark can't go all the way and go all the way through the torch and get into the hoses and then eventually go to the cylinders. Obviously, you would have like a huge a catastrophe or an accident on your hands. So flashback arresters are very key. After them, we connect those to our hoses. Hose on the left, oxygen, hose on the right is acetylene. you take a look, everything is color coded with green and red. Oxygen is mainly going to be green and red. Acetylene is going to be all red for the hoses. The regulators are going to be red. You might see the cylinder either be red or black. Down here we have our cylinder caps. Obviously green for oxygen, red for acetylene. We always want to make sure if we're ever going to move a cylinder that those caps are put on securely and tight. The cylinders always remained upright position. We use a cylinder cart, and we also have it chained up at all times. We want to make sure that if we do have to move the cylinders, we're taking all the safety precautions. So if we follow the hoses, they go back to another flashback arrestor. This again is going to stop any kind of flame from coming and getting into the regulator. Sort of like the last line of defense before it would get to the cylinder. Our acetylene regulator is red. Our working pressure is going to be on the left. Our cylinder pressure is going to be on the right. This kind of horizontal line there is an adjusting screw. That's how we're going to dial our pressure in. After we open the valve on the cylinder itself, you'll see the gauge on the right tell you how much the actual pressure is in the cylinder itself. Then with the adjusting screw, we'll start to add pressure in that is going to go through our hose and get to our torch. If we follow our green hose, our oxygen hose, it comes up, same sort of setup, flashback arrestor before it gets to the regulator, working pressure on the left, cylinder pressure on the right. The cylinders, they have what I call a gate valve, what I think the book calls a hand wheel kind of top. I've never seen this style. I think this must be an older type style with the valve wrench on it. We get our cylinders at the school from Airgas, so all of them I've seen come with just the hand wheel cylinder valve on top. Most cylinders nowadays, when you get them, they'll come with some kind of plastic or wrapping around the cylinder valve just to make sure that the cylinder is completely full or has been recharged. If we look from the pictures in the book, figure 12.1 and 12.2, here's a better, more in-depth look at the torch itself. This obviously is a cutting attachment. The welding tips is going to have this 45-degree angle to help us when our working angle for when we weld. This is our torch body. These two valves here are those needle valves that I spoke about. The fittings where the flash arresters or check valves are going to be put on. Our hoses, they're usually kind of molded together, so you have both an oxygen and acetylene hose. You look on here, here's our oxygen regulator, working pressure on the left, the low numbers. The high numbers is for the pressure in the cylinder. Same as, then we talk about the adjusting screw. This is where we would dial in our pressure on our gauge on our left. This is the fitting that would actually hook into the cylinder valve for either oxygen or acetylene. The thing about the big difference between these two is acetylene is going to have a left-handed thread. Oxygen is going to have a right-handed thread. So oxygen would be lefty-loosey, righty-tighty, and acetylene would be the opposite. It would be righty-loosey, lefty-tighty. This is a way, if someone were to be colorblind, that they would know the difference between the two. Here we have an example of welding goggles. These aren't flip-ups, so it'd be a little tough to wear because you'd have to set them down right before you were getting ready to weld. Here is an example of a striker, which we light the torch with. Here's a look at our cylinder cart. This is a different one than we have at school, but still works the same. You see the cylinders are in upright position. They're chained up, just kind of tilted back, almost like a dolly, cart dolly, same kind of principle. Our first safety slide: keep oil, grease, and other petroleum products away from the welding area. Petroleum products are highly combustible in the presence of oxygen and could spontaneously combust. So anytime when you're dealing with that cylinder valve up top, you don't want to clean the debris out with any kind of petroleum product, because when you open that cylinder, that pressurized oxygen mixed with petroleum is very highly combustible. You have a catastrophe on our hands. So anytime you think there's some debris, which, like I said, most of the cylinders now come, once they're recharged or filled, they come with a plastic cap or some kind of lining so that there's no debris that gets caught in there. You always just kind of want to crack it to make sure that it blows out that debris before you hook your regulator up to it. You obviously don't want to be right in line with it when you open it. You kind of want to point it away from you and just crack it. You'll blow anything that's around the connection for the regulator to the cylinder. Oxygen supply. Oxygen for welding is stored in cylinders of various sizes. The cylinders are commonly painted green. A gauge pressure is about 2,200 psi when it is completely full. A Dewar flask is used to store liquid oxygen. These, I worked at a welding shop in Steelton called Osage Piping. We had one of these Dewar flask containers for oxygen. They're more commonly seen at like a hospital where you have a lot of different oxygen hookups. You need a lot of pressure. Like, I'm not even sure how much oxygen is contained in one of these, but I know it's a ton more than just a regular cylinder. They're a lot bigger. If you're following along in the book, or if you've read the book already, you know that the book goes in depth in the construction of the cylinder, the construction of the cylinder valve. We're not going to go crazy into that. Just make sure that when you open a cylinder, an oxygen cylinder, that valve is completely open, because the parts inside of the cylinder valve have to seat. That pressure from having it wide open seats all that stuff, so you don't have a leak. You don't want to have a leak. You want to make sure that that valve is completely open. Safety: while in use, the cylinder valve should be turned all the way open. There you go. A cylinder truck should be used to move cylinders. We already took a look at that. Cylinders should be secured in vertical position. You've seen how they were upright. They were chained up. I know air gas, just from experience buying cylinders, they won't even let you leave or even purchase a cylinder if it's not able to be in a vertical position or standing straight up, secured to your truck or vehicle. It's not good for the cylinder. It's very dangerous. So that's like one of their big rules when you come to air gas. You got to make sure that the cylinders is upright and secured at all times. When moving a gas cylinder, proceed slowly. Cylinder should always be kept valve end up, and the valve should be closed when the cylinder is not in use. I mean, we're not going to have to deal with the cylinders themselves, but the manifold system is under the same guidelines. We're going to turn the valve off that provides the oxygen in from the manifold. So that'll be like the first thing we do when we start to close down for the night. Acetylene cylinders. Acetylene gas can be stored in specially designed cylinders. New empty cylinders are filled with an inert monolithic filler metal. Cylinders are charged with acetone. Acetone makes the cylinders are charged with acetone. They make the cylinders are charged with acetone, and acetylene gas is pumped into the cylinder where it is absorbed by the acetone and stored in the pores of the filler metal or material. The book does a great job of describing this, so let's take a look. So here we have a drawing of an acetylene cylinder. We have our removable cap. The valve is underneath that. We have two fuse plugs on either side of the cylinder valve. They're a safety measure or safety precaution. If any kind of heat or molten metal or sparks fly onto those fuse plugs, they'll be able to release the gas out of the bottom. If we look inside a cylinder, as they cut it out, we have that monolithic filler porous material that the acetone is inside, and then you have the actual inert gas, acetylene gas, poured into the cylinder itself. The acetone makes it non-volatile, and another reason why you don't want to lay this on its side, you want to keep it vertical at all times, is if it's laid on its side, all that acetone will run to one side, ruining the cylinder if it's for a prolonged period of time. So we always want to keep them upright. Also, while I was looking through the book, if you guys haven't noticed, this is a manifold type system. This is similar to what we have at our shop. You have your master regulator with a manual shutoff valve, and then you have all the cylinders. All 4 of these cylinders are hooked up, so you have multiple cylinders on one entire line. We have 9 stations right now in the shop, so instead of having all those cylinders right next to one another, we can have our cylinders in a safe block room separated from the acetylene and have it plumbed in to the shop so that every one of those stations can have oxygen and acetylene. Acetylene cylinders, the amount of acetylene in a cylinder is determined by the weight, not the pressure. Acetylene cylinders should be stored and used upright. Acetylene cylinders come in a variety of sizes. These littler cylinders are used more for HVAC. They're a little bit more portable. You don't need as much acetylene, obviously, when you're doing that kind of work, soldering or brazing. So you don't need these huge tanks. Like our manifold system, we have like the biggest acetylene cylinders that you can buy. If you notice too, the acetylene cylinder looks like it's half the size of the oxygen cylinder in most cases. And the oxygen cylinder will have 2200 PSI if it's full. An acetylene cylinder will have anywhere from 240 to 250 PSI, yet you'll go through almost 2 to 1 oxygen over acetylene because especially when you're cutting, not so much when you're welding, because your PSI for each, for acetylene will be 3, and for oxygen it'll be around 3, 5 to 3. When you're cutting, then your acetylene's usually about the same, but then your oxygen, for instance, we'll be using it at 30 PSI as opposed to the 3 PSI. So you're almost 10 times more oxygen to cut with than acetylene. So usually it's about almost 2 to 1, you'll use your oxygen over acetylene. Allowing too much acetylene flow can be dangerous. A pressure drop could occur that might cause a flashback. Flashback is a condition in which the flame burns inside the torch or hoses. If this occurs, shut off the gas immediately. So if you have any kind of pressure drop, you're going to get a flashback. A backfire is going to occur anytime the flow of gas stops. So if you take your welding tip and actually drop it onto your base metal and the flame goes out, then you're going to hear a pop. A flashback, some kind of debris came up through the hole at the end of your welding tip, and it's going to sound more like a machine gun. You're going to get pop, 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 or like a high-pitched shrilling sound. Like I can't do it right now. Anytime you hear that, take your needle valve, shut them off. If you get kind of you get nervous or get excited and you don't realize the needle valves, the best thing you do is set the torch down, put it in the grating, go to your manifold valves, and turn it off there. We want to isolate the flow of gas when this flashback occurs. If you have it in that constant state, those flashback arresters, they're only rated for a certain temperature and it could ruin them. So we want to make sure anytime that we have a backfire, flashback, anything like that, we want to turn the gas off immediately. Acetylene is unsafe to be used above 15 psi. Again, we're going to hear that. This is what, the second or third time already in this video. You're going to see it, hear it all the time throughout the book. There's chapter 13, 14, and 15 are all dedicated to oxyfuel welding or cutting. So 15 psi, they stress, stress, stress. And like I said, we shouldn't be anywhere near that, so we shouldn't have to worry about it. But and if you notice, if we go back to the acetylene regulator, let's see. Here's an example of an acetylene regulator. And on the left side, remember I said working pressure. On the right side is the pressure in the cylinder. If we go up to 15, you see this red background indicates dangerous pressure settings. So we're going to be, this is 5, 4, 3, this notch here, we should never be anywhere near all the way up here. So this is just an example to show you how this 15 psi, you don't want to ever be in the red zone. This isn't football. We want to stay out of the red zone. Sources of ignition must be permitted in acetylene storage, or must not be permitted in acetylene storage areas. Acetylene can form explosive compounds with copper, silver, and mercury, and must be kept away from these metals and their salts, compounds, and alloys, and keep cylinders away from overhead welding or cutting. If you go to this link, it's a video from Texas where there was an acetylene plant, manufacturing plant, where they did the acetylene cylinders. They had an accident there and it basically almost blew up the entire plant. They tried to put the fire out, but because the bottles were starting to explode, the cylinders were flying for almost miles. So it's crazy video, and we don't want to have anything like that on our hands. But it does show you how severe it is and how dangerous working around acetylene, especially when you have it hooked up to a manifold system where there's multiple bottles working. You know, once one goes off, it sets off like a chain reaction. Pressure regulator principles. A pressure regulator is installed between the cylinder and the torch lines to reduce and stabilize gas pressure. Most regulators have two gauges. A high pressure gauge shows the cylinder pressure. A low pressure gauge shows the working pressure. If we click back on just the example of the acetylene one, again, the low numbers, you always want to go off the numbers on the inside here. So 5, 10, 15, and if we look over here, 50, 100, 150, 200, 250. This is right around where a full cylinder should be. You can see the low numbers versus the high numbers. Here's an example of an oxygen regulator. Two varieties of regulators are available. A single stage regulator will reduce pressure in one step from 200 to 5 psi. Two stage regulators will reduce the pressure in two different steps, 2000 to 200 and then 200 to 5. Ours are going to be the single stage regulators. This is a single stage regulator. A two stage regulator will actually have another, the back of it, it's a little bit bigger where the gas comes in that first chamber and then it gets reduced and then it comes out to the first stage. Two stage regulators provide more accurate pressure controls and readings. The flow of gas from the cylinder stops completely when the adjusting screw of the regulator is turned all the way out. So obviously to dial in your pressure, you're going to have to turn your regulator screw clockwise and turn it in. Fuel gas and oxygen regulators and gauges must not be interchanged because a fire or explosion may result. You don't want to change regulators out. I don't know why you would ever do that. Again, that's why I think another reason why they're color coded. So red stays with acetylene, oxygen is green. You keep all that stuff the same. You never want to interchange them. Welding hoses. Hoses are built in several layers for welding hoses. Hoses are built in several layers for strength. Common colors are black, green, and red. I don't know why they have black here. I've never seen a black hose. Some of the cylinders are black, but I've only ever seen red and green color hoses. The hose is specified according to its inside diameter. Double hoses are also available. Unfortunately, twice in my career, I had situations where my acetylene and oxygen hoses were damaged, whether it was falling material or sparks and molten metal. I was above the hoses both times. You know, I had over 200 foot of hoses on my truck. So I was all the way through this building the one time, and I'm not, like I said, I'm not sure if it was debris or if it was, you know, the molten metal that was coming down on the hoses. Either way, the hoses were damaged. Flames are shooting out of the hoses. But because we had the check valves, the flash arresters on the regulator, the flame did not come back through and get to the cylinders. We were able to shut off the cylinders both times before you know, we had a catastrophe or major incident. So yeah, those are huge, and the hoses are very durable. You're going to see spots even in our shop where the hoses might have, you know, were on something warm and they're worn a little bit, but they are multiple layers. They can withstand a lot of stuff. We just want to make sure when we're in there, we're welding or cutting or anything like that, we always have an idea where our hoses are at and where those sparks are shooting and where that falling hot metal is going. We don't want to chance it. We want to make sure those hoses are out of that line of fire. Special precautions are used when attaching the hoses to the regulators. The nut used to connect the nipple on the oxygen hose to the torch or regulator has right-handed threads, like I talked about earlier, lefty-loosey, righty-tighty, and may be marked OXY. The regulator and hosing fittings for the acetylene have left-handed threads, lefty-tighty, righty-loosey, and may be marked ACE. Safety slide. Hoses must be handled carefully to prevent accidents. They must not come in contact with any flame or hot metal. They should not be kinked sharply. During the welding, hoses should be protected from falling objects, vehicles, or foot traffic. This last one, we want to make sure that, you know, when we're welding, where our stations are located, there are welders behind us, that we don't have the hoses out into the aisle, which becomes a trip hazard for students that are walking back and forth. We also, like the hoses that are on our torches in the shop are fairly new, so they are a little cumbersome to kind of work with because they haven't always been stretched all the way out. We're working in our workstations are only going to be, you know, 3-4 feet of hose is all we're going to need, maybe a little bit more, but the hoses are probably 20 foot. So they are kind of a pain, you know, to try to get comfortable. And that's going to be an issue because to weld, one of the key things to welding is being comfortable. So when you get in there, kind of before you even light the torch up, make sure you can adjust and move around with the torch and it's not cumbersome for you to kind of work with. Flashback arresters and check valves. Flashback arresters eliminate the possibility of an explosion in the regulator or cylinder. A check valve allows gas flow to only one direction. So like when I was talking about when I had the damaged hoses, yeah, there was flames flying out the end of the hoses, but that flame was not coming back through and getting to the cylinders because that gas is only moving in one direction. Flashback arresters features reverse flow check valve. This will stop the flow of gas in the wrong direction. Pressure sensitive cutoff valve cuts the flow if an explosion or flame occurs. Stainless steel filter will stop the flame, and heat sensitive check valves, which will stop the flow if the arrestor reaches 220 degrees. That's also the number with our fuse plugs. A flashback arrestor cannot be used after a sustained flashback or after reaching 220 degrees. That's why when I talked about having a flashback occur, we want to shut the flow of gas off immediately. That way we don't ruin those check valves. Here's a good look at a check valve. You can see we have our fittings from our torch, the check valve in between, and then our fittings to our hoses. That's another good look at the check valve. See how the flow of gas is only going to come one way. See how they're marked green and red too, to define which one's oxygen and which one's acetylene. Oxyacetylene torch types. There are two types of oxyacetylene welding and cutting torches. There's a positive pressure one. That's the kind that we will use. There's also an injector kind, which I've never used before. I did get a picture of it if you want to see one. I've never seen one out in the field. Positive pressure torches are far more commonly used. Positive pressure welding torches. The torch consists of four main parts: a body, a hand torch valve, mixing chamber, and tip. What I've referred to this hand torch valve as a needle valve. I always call them a needle valve. That's how I was taught. So you'll hear me say needle valve instead of hand torch valve. So if we start here, again, this is the fittings for the torch itself, where our flashback arresters will go on. And we have our needle valve, the torch body itself, where there is an oxygen hose and acetylene hose that runs up to our mixing chamber, which in this case is our welding tip is connected to. And that's where the magic happens. That's where both gases are mixed together, come out your welding tip, striker, and light it up. Positive pressure welding torches. Oxygen and fuel gas are mixed in the torch and burn at the end of the torch tip. Needle valves can be used to throttle the gas being fed into the torch. The mixing chamber is usually located inside the torch body. Once we regulate our pressure at the regulator with our adjusting screw, we then turn these needle valves to get pressure or the gas to come out the end of the welding tip. We'll go over this in the next chapter. The way to do it is quarter turn with gas for your acetylene. Light the torch, you'll have a flame, then start adding your oxygen in as you go on. Welding tips. After the gas is mixed, they are fed through the tube to the welding tip where combustion takes place. The tip orifice must be the correct size. We're going to use a number 2 tip with our acetylene pressure being 3, our oxygen pressure being 3 or 5, roughly in there. The larger the number, the larger the hole. The larger the hole, the bigger the flame, the thicker the metal you can work with. We're going to be working with 1/8" steel, so it's best for us to use the 2 tip. Always use tips made for the specific torch on which they are being installed. You can see all these different sizes. Obviously, the bigger you go up, the larger the hole, the thicker the metal you can weld on. Welding tip cleaners. The orifice must be kept smooth and clean. Welding tip cleaners have a series of broaching wires. You can see these broaching wires and then the file on each one. The diameter of each broach goes from small to large. There's also a flat file in there. A broach is a tool used to shape the hole. A drill bit with the correct size can also be used to clean the tips. Unfortunately, we're going to get very experienced or a lot of experience with with these welding tip cleaners. Um, we want to keep those things clean as much as we can, and they're going to get a lot of debris on the end of the tip that's going to need clean. That hole is going to have debris come in up in it at certain times, and we're going to have to clean that out. The big thing with the broaches is I would recommend going a couple sizes smaller. You don't want a broach that is almost the exact size of the hole on the end of your welding tip. It's not a cannon. We're not trying to plug something down it. We're trying to just clean out the debris around it. So go a tip size smaller and just kind of file that out. If you make that hole bigger, if that hole becomes bigger, more gas flow is going to come out of that hole than is necessary or than that's supposed to, and the welding tip is going to be ruined. You're never going to be able to achieve a neutral flame, and like I said, basically that welding tip is no good anymore. If the welding tip becomes no good, get it to me. Don't try to fight it all night trying to get a neutral flame. If it's not working right, we'll get you a new one. But that flat file, the best way I would do it would be, and I'll show you this when we get into the shop and we learn how to light the torch and everything. You take that flat file, if this is the welding tip, just make sure that's nice and flat. It's nice and clean, nice and shiny on the end, and then start using the broach to kind of fix the hole around it. If there's debris or there's weld or slag or anything on the end of that tip, we want to make sure that's clean first. And when you're filing it, you got to be careful that you don't put a bevel on it. You want to make sure that's nice and completely flat. If you bevel it, there again, that's going to screw up the flow of gas, and it basically will ruin the welding tip. Welding goggles and protective clothing. Welders must wear suitable goggles or glasses with a face shield or a welding helmet with a proper filter plate. Shade 5 is the number filter you should use when welding or cutting. Filter lenses are made in a variety of shade intensities. A clear cover lens is used to protect the filter lenses from metal spatter. If you're going to use your welding helmet, you want it to have a grind mode so that you don't go dark, especially if it's an auto darkening one. If it goes dark on you, it's going to make it a lot more difficult to weld or cut. Most auto darkening helmets nowadays have a grind mode so that when you have a spark or a light or whatever, your auto darkening doesn't go dark. It stays see-through so that you can see. Usually your filter lens, the basic one, is I think is 7. So you'll be more than protected if you're going to wear your welding helmet. You just want to make sure it's on grind mode. Here's a look at a welder with the face shield that is a shade 5, that you see that green tint. Most of your shade or your cutting goggles or your cutting glasses or this cutting face shield is going to have that green tint to it, shade 5. See, he has regular safety glasses on underneath. You want to double protect yourself at all times. Even if you have your welding hood, you're going to have your safety glasses on underneath. And this does, you know, 2 things. It's protecting his eyes with the shade 5, and it's also protecting his face from any debris or sparks or anything like that. Welding goggles and protective clothing. Welders must always wear protective clothing. Hands should be protected with leather gloves that are a gauntlet type or have elastic bands. The gauntlet type means it comes like up over your forearms. Jackets should be made of leather or fabric treated to resist burning. Pants should have no cuffs and should be made from fabric treated to resist burning. You know, most students, they like to wear the heavy leather gloves on their filler rod hand because the heat kind of goes up the filler rod more often than not. So you want a heavier glove for your filler rod hand, and then most use for their lighter hand, the hand they have their torch in, a lighter glove. It's easier to kind of move around. You're not going to get much heat on that hand, so it doesn't have to have like a heavy glove. Jackets, they don't have to go crazy with like the huge suede leather jacket like you would for arc welding. The sparks are not as intense. You're not going to be doing this overhead or anything like that. So even if you didn't have any kind of welding jacket, if you wore sleeves, denim shirt, long sleeve shirt, anything, I would try to stay away from cotton as best you can. Just kind of layer up. You don't have to go crazy with this because it's not going to be a whole lot of sparks and danger from like molten metal. Pants, obviously, you know, jeans, it will be fine. Just don't cuff them. You don't want to get any sparks to kind of lay inside your pants. The handheld flame should never be used to light a welding torch. That goes back to the striker. Do not carry matches or combustible materials while welding. If you got cigarette smokers out there, just try to keep your lighter in your bag or something. Don't have it on yourself. If a flame or a spark would come down, and you know, there we'd have a bad accident. And if sparks enter your pockets and clothing, that could be a serious burn may result. So any kind of open pockets or anything like that, you want to make sure they're closed. A lot of times when I'd be welding, I had my cell phone in my top pocket, but I wouldn't have it flipped up, and you know, I would get sparks in there, and then my cell phone's ruined. Done it many times. So just be careful with pockets. A flint and steel spark lighter or striker is the most popular type of torch lighter. Pistol grip spark lighters are also available. I don't want anything like you light your grill with. Just buy a striker. They're like $1 or $2. Just make sure that's what we're using the light with. Oxy-fuel gas welding supplies. Many supplies are needed to perform oxy-fuel gas welding. Welding gases, welding rod, filler metal, fluxes, fire brick, carbon paste, and forms. We won't use fluxes. We won't use these carbon paste and forms. The fire brick is going to be something we can set our material on so that it's, you know, close to us or in a position that's comfortable for us. Filler rod or welding rod is what we're going to make our welds with. And then obviously the gases we've been talking about, acetylene and oxygen. Other fuel gases, though, acetylene is the most commonly used fuel gas for welding. Other gases include hydrogen, LP, or liquid petroleum, or liquefied petroleum, propane, or butane, natural gas, and polypropylene-based fuel gases. That you'll see more with silver soldering. I have worked at companies where natural gas was used or LP gas. It's cheaper. So a lot of companies do use it over acetylene, but the big thing would be like natural gas is very hard to light and very hard to keep lit. LP gas doesn't burn as hot. So acetylene, yes, you're paying a little bit more for it, but it's easier to light, it's easier to work with, it burns hotter. It's the most common, but there again, there are some companies that are trying to save a buck everywhere they can, so they'll go with the lesser or the cheaper brand, but you're going to, in the long run, you're going to end up paying with it. It's a little bit more difficult to work with. And finally, the welding rods for oxy-fuel welding. The American Weld Society, or AWS, issues specifications for all types of welding rods and electrodes. The ones we will be using will be welding on carbon steel, and I think it's the RG45s is what he ordered there. The RG is rod gas, which it's a welding rod, and we're using gas to weld with. The 45 is 45,000 PSI or tensile strength. So if you make 1 inch of weld by 1 inch of weld with this rod, it can withstand 45,000 pounds of pressure. That would be plenty for what we're going to be using it for. Obviously, the stronger, or the higher the number, higher the tensile strength, the stronger the weld is going to be. Well, that's the end of the chapter. I want to thank you again for clicking on the video PowerPoints for Chapter 12 in your Modern Welding textbook. Hopefully this answered any questions you might have had about the chapter after reading it. If you still do have questions, you can always email me at dekurtz@hack.edu. I want to thank you again, and goodbye.